Hello and welcome to another free code session. My name is Jason Bach and I'm going to do some changes on range. I've been thinking about this a little bit, and there are some things that after I looked at the changes I did make on range, which I actually thought were for the better, I've thought about some things some more and I'm going to change things a little bit again. These will be breaking changes, but since we're doing breaking changes anyway, who cares? I am going to make it exclusive end, in part because I think that matches the range type a little bit better. It matches how people think of ranges in computer programming languages a little bit better. I was looking this up in other languages, seem to always do exclusive end for any kind of range type they have. It also will make something at the bottom, I think, a little bit easier to reason about. I'm going to make it a read-only struct. It is read-only anyway, and it probably should be dealing with other struct types. So even though I don't constrain it to be that way, it could be something I say too is that it should be a struct, but at least I'm going to make myself a read-only struct. This is a minor change, moving preconditional checks to partition. And then this one is the kind of influences the first one, which is right now I'm constraining it to I binary number. And the reason that I want to change it to exclusive end is because I want to make this I number, which means you could give floating point numbers. In fact, I have some notes here. And like I'm saying, it would be kind of cool to do this, but then how do you do an inclusive end and say, like, how would you do, if you wanted to say something was within that range? I was thinking about this before and I'm like, that's the problem. If we wanted to do partition, well, how do I say this is part of the partition for the first one and the second one it can't use that same number because that one can't be in this one. Like the end of the first can't be in the beginning of the second. So if you make it exclusive end, you can use the same number, but in the first range, it means it's exclusive. So then all of the single numbers that you can think of that fit between that inclusive beginning and that exclusive end just works. So that does mean I have to change some implementations, but I think this is the right thing to do. So this will allow me now to say I can have a range of a floating point type. And I'm kind of like, let's just play with this. Let's see where this goes and let's see if this makes sense. Okay, so we get rid of that. And we got this. Now if I say, by the way, if I just say binary integer. I don't think there's an integer here, by the way. Yeah. We're just going to say I number. Okay. Maybe I number base. I don't know I actually did not look at what defines the base for other number types. Okay, that makes sense. If I do that, suddenly this goes away. But if I say number here, I believe that has everything we need. So defines a number type. Okay. So that makes everything just work, okay? Now let's go through some of these things and let's change partition, at least for how we're doing it right now for binary integers. And we'll say the end of the range exclusive. By the way, as I noticed before, this is going to line up with this, which is actually not doing it right now, which is this is an exclusive. And because our range type is inclusive, it was saying, oh, that should be inclusive, but it wasn't. So this is actually, I think, the right thing to do anyway. Okay. If they're reversed, I don't know. If this was 3 and that was 2, did you mean 2 and 3, but then 2 and 3, 2? Yeah. I'm kind of thinking if this is actually the case, that doesn't make any sense. I don't know if I ever run into a case here where I say they have to be constantly flipped. I don't think I do that. I would have to do that here though, which is Because as we found out in a couple of episodes before, you can define a range to be flipped, but if you pass that into an array to get indices, it doesn't work. It gives you an exception. So it just seems odd to have a range, especially when the end needs to be exclusive. Well, how do you then say that's the beginning and it's inclusive, but the end is exclusive? Now that was the start. I don't know. I'm kind of leaning towards, if this is what you get, throw new argument exception. The start value. And actually, we couldn't say less than or equal to. It has to be strictly less than, right? We can't say that. We have to say that. Because if it was equal, then we could have 2 and 2. Or we could have 3.2 and 3.2. Well, that's an empty range. That doesn't really, it's a range of nothing. And especially now that we're going to have an exclusive end, I think we need to say it's strictly. Yeah, I'm kind of, the start value, start must be less than the end value, end. Okay, and then we'll do that. Or we could just say that. I mean, same thing, because reasons. All right, so we need to put a test in here, test for start being greater than end, and start being equal to end. There we go. Okay, so we got that. A equals B. Yes, because then we pass it into here, which we're going to make this a read-only struct. Get that out of the way right now. Ooh, what did that do? Does not implement interface member I equatable equals range of T. Really? It doesn't? Oh. Okay, because yeah, it's actually, and oh, yeah, okay, fine. Get rid of that. And then, yeah, this, I guess we just reduce it down to that, right? And what are you complaining about? Return. There you go. And since this is no longer, since it can't be null, contains, now this is saying it has to be less than that. So we need to update tests for contains. This is all okay. I mean, I kind of figured this would take some churn to do this, but now we're saying inclusive or exclusive. Here we're saying, so if I had a range of 3 to 6, and I gave a range of 3 to 6, I had to pause on that for a second. Does it contain it? I'm not sure. If we think of integers 3, 6, you'd have 3, 4, and 5. If I said contains, then it has to contain the start value. That makes sense. And it needs to contain 1 less than. But 1 for a double, I mean, it could be half of it and it would still be in the range. So I'm not really sure if this makes sense anymore. Like, where's it all being called from? Well, it's only being called in one spot. So I think if that's the only place we're doing it, then I kind of think maybe let's dump it, because I don't think it makes sense to do that here. We know it's not going to be null, so we can say that, which means we could just say return. And then that, which is fine because if you think about it, this being equal to, like, it has the same exclusive end value, so that's okay. And now we would say here, yeah, thanks. I really appreciate it. What would you do? I forget, what's the rule of a struct implementing equality? Like, you can't say here, what happens if it's not? Hold on. Okay, I had to go look at an old program that I wrote. There's the Quixel game that I wrote, but then there was a game I made of it, a 3D version with another friend of mine, Mike. And this is what you do. You basically say, if it is that, then you can call it and cast it, which makes sense. So in this case, we want to say, make it a block body, and we want to say var r equals false. We're going to return r equal, and then we're going to say if obj is range of t, then we're going to basically do this. What are you complaining about? Oh, use pattern matching. Sure, makes sense. Sure. Okay. And we could say this, otherwise we'll just return false. That's a little cleaner. I like that. Okay. Get hash code, that's fine. Intersect, we would never have a null. We could have a nullable intersection because, yeah. Now, this is where what I did have, it needs to come back. Because, like how I did the intersect before when they were exclusive ends. And I took all that out. If I go to range extensions here, oh no, I didn't. Oh, that's right, because I made them. I'm starting to overthink this. If I make it exclusive end and I say intersect, how did I do this before? And again, if I try to make it so that it's doubles, which I think should really be a thing, you notice here I'm saying less than or equal to. What would you actually do here? And I feel like whatever I'm going to do, it's going to be wrong off the cuff. Though it does make sense if you're saying they're both exclusive ends, either if they're doubles or integers, it wouldn't matter which one is. Yeah, I think that's okay. I'm going to go with that for now. And then the intersect, inclusive of the range, the end value, exclusive. My phone buzzes very, very loud. We'll come back to that. So now partition. If this start equals this end, we would never run into that, right? There is no way to, yeah, they're the same. But we don't stop it either. You know, if I say, maybe that's why I had equal here. Yeah. Because you can't do this. You can't have like 0.2 and then 0.2. You're excluding the included. The start must be strictly and the other way. The start cannot be greater than or equal to the end. It has to be strictly less than the end. And I bet all this is wrong up here. So there is no way to hit this. You would never have this. You could have this, which is saying the number of ranges is less. You need to say, I have to have some kind of range. Now, here's where it gets interesting, though, because when you're doing integers, they do have discrete values, okay? So if I had like the end is 2 and the start is 1, that's 2 minus 1 is 1. The range difference is 2. That really doesn't make any sense. Like if you, I'm not sure I agree with that. What was it before? Yeah. I don't think you do that anymore. But if you say the end minus the start, the number of ranges must be greater than or equal to the range difference. Which I get why I'm trying to say this, because if you say, I've already said it has to be greater than 0. Okay. So now if you gave me at least a 1 and you had an exclusive 2 and an inclusive 1, that'd be 2 minus 1, which is 1. So that 1 is not less than 1. It's, I guess you could say, the number of partitions. I think that's what you're really saying here. That's the number of partitions. Partitions. Okay. And if you had 0.2 minus 0.1, 0.1, this again is where this right here to split if t is a floating point number or something. I don't know if it's actually that, but I think there's a case where you want to do and say, then that would be okay. Because what you're saying is that number plus, it's some really small epsilon to that number. And if I wanted to go from 0.1 to 0.4 and do it in 3 partitions, that would be perfectly fine. Because you go from 0.1 to 0.2, 0.2 to 0.3, and 0.3 to 0.4. That makes absolutely perfect sense. But in this case, we're saying that, it actually has to be, if it's a binary number, then some certain cases come up. And I think that's what we're saying here. So this is all for if you have, now I also have to do this the way I was doing it before, except we don't have to worry about reversing because we don't have to worry about that. So we say 0, number of partitions. The partition range is the new range from k to minimal partition range size, except I no longer say -1 because I don't have to subtract it. Okay. And I think it's saying there's an unnecessary parentheses here, which I agree with. Okay. Now this one is saying k is now the end value plus 1. We do not need to say that. Remainder is 0, t is 0, and we add the range. We don't have to worry about reversing. We don't have to worry about reversing, and we're done. So that would still be the same. That overrides. We could say here that. Because I think, hold on, let me look that up. I'm glad I looked it up because it actually needs to be the second one. Inclusive is the bracket. Exclusive is this. And I'm going to grab this because I think there is like a, but hold on, let me just, oh brother, my son is, so this is saying inclusive, that's saying exclusive. Yes. So this is actually the one I want. I'm grabbing it for notes reasons. Okay. Because I need to put that in there so I remember, hey, that's what I was talking about. Okay. So yeah, we now have that right in the format start end. There we go. Now the union, we could have a nullable union come back because the current range contains a target range start, or does the end. Or the target range contains the start, or the target range contains the end. So the intersect start, we were saying target start, this end, I think that's all good. So I think we've now got to the point where this is kind of what I want. Now I've got to update a whole bunch of tests. So I'm going to do that in the next episode. Before I do that, I'm going to clean up a couple things with comments and things like that in here and just make sure I think I've gone through this again to do it right. In the next episode, I'll clean up the tests that currently exist for this range, and then we'll implement partition using a floating point number, and we'll see if that all works the way I'm expecting it to. Thank you all for watching. Leave comments and questions below. See you in the next episode.